So another important factor is problem-solving tips for Coulomb's law. So use consistent units. SI units are always the best. To find electrostatic force on a single charge due to two or more charges, find the force due to each separately. The net force will be the vector sum of all the forces. It is often helpful to resolve forces into its components, add components together, and then find Fx and Fy. If several charges lie along the same line, don't worry about interaction between the charges. Remember, the gravitational force between Earth and the Sun always stays the same and does not change when the Moon comes between those two. So now, in order to help us understand it, let's do an example. The electrical force on a point charge. Suppose 3 point charges are arranged as shown in the figure. The charge Q1 is located at the origin of an XY coordinate system. The second charge Q2 is located at 1.2 and 0 meters. What is the force on Q2 due to the other two charges? So in order to solve a problem like this, first of all, let's draw what the coordinate system is going to look like. So for us, we are going to have one charge, and I'm going to suppose that this is where my origin lies. Okay, and then I'm going to go further from here. So this is my XYZ coordinate system, right? And I'm going to say that my Q1, it says it lies at the origin, and it is 1.2 microcoulomb. And then my Q2 is at, so my Q2 is equals to minus 0.6 microcoulomb, and it is at 1.2 and 0.5, so about here. And then Q3, which is positive, so this is plus 0.2 microcoulombs, 1.2 and 0. So what is micro? Micro is basically 10 to the minus, micro is 10 to the minus 6 coulomb. So just so you remember that, I'm not going to rewrite it again and again, so it's just something we'll have to remember. Okay, now, what do I need to do? I need to find what is the force on Q2 due to the other two charges, okay? So, as we talked about it, this is going to be a calculation with vectors, so we're going to concentrate on vectors. So first of all, because we're going to be using Coulomb's law in this case, I need to find the charge separation, or the radius between these two. So I need to find the radius between these two, and I need to find the separation between these two. Okay? Well, this one is easy. If I was to find the coordinate system, this is about 0.5, right? And also, this one is easy because it's just 1.2. Now, how do I find the separation between this? So if you can tell that this is actually a 90-degree angle, so I can use Pythagorean theorem, which is going to be 1.2 squared plus 0.5 squared square root in order to calculate what my R is going to be for there. And I calculate it to be 1.3. Now the next question is, how do I find it? I know that these are forces, so there must be vectors. So how do you do this? I think it might be worthwhile to just find F12 first and F32 first and then add them up as vectors. So in order to do that, let me find F12 first. So F12 will be equals to K Q1 Q2 over R12 squared. Okay? What will it be? 9 times 10 to the power 9, not worrying about units right now. This will be 1.2 microcoulomb, which I know is going to be times 10 to the minus 6. And then Q2, which is minus 0.6 times 10 to the minus 6, divided by R12, which I just calculated it here to be 1.3 squared. Okay, once I plug in all my numbers, I believe I get minus 3.83 times 10 to the minus 3 newtons. So F12 is going to be that. Now what about F23? The other thing I need to calculate is F23, which is going to be K Q2 Q3 over R23 squared. Similarly, I can put in the values 9 times 10 to the 9. Q2 is minus 0.6 times 10 to the minus 6. Q3 is plus 0.2 times 10 to the minus 6. So if you notice, all I'm doing is putting numbers in divided by R23. R23, which is 0.5. 0.5 squared, and if I've done my math correctly, I get minus 4.32 times 10 to the minus 3 newtons. So F23 is going to be that. Now, the next question, can I just add these two up to get me the force on it? The answer is unfortunately no, because these need to be added as vectors. So in order to add them as vectors, what do I have to do? What do I need to do? Well, I need to find the components of each of them in the x and y plane. How do I do that? Well, at this point, I need to go back to this figure and try to calculate what I mean when I say I need to figure out what the x and y of these two things is. Okay, problem 1. I don't know the angle. How do I find the angle? I need to find this angle right here, but I don't know what angle that is going to be. So what do? Well, I have this, and this. I could calculate cosine theta, which is going to be base over hypotenuse. So my base would be 1.2 divided by 1.3, which means theta comes out to be 22.6 degrees. Okay? Once I have that, that makes me feel better. I can actually calculate sigma f. Well, I can calculate f1 to x by putting in values cosine of theta, and I can calculate f1 to y sine of theta. Since I have cosine, if I have theta, I can just calculate cosines and sines. I calculate these to be minus 3.53 times 10 to the minus 3 newtons, and I calculate this to be minus 2.48 times 10 to the minus 3 newtons. Okay? This one is slightly easier because the direction of the force is going to be between these two. So I know that my angle between them is going to be 0. So this means F23x will be, and F23y will be that. Now, this means my total fx will be f1-2x plus f2-3x, and my fy will be f1-2y plus f2-3y. All I need to do is plug in some numbers in order to calculate what my total f net will be total fx plus total fy. Okay? What I want you to do now is to calculate what the value is going to be, come up with an answer. Okay? I calculate that my total f, I'm going to skip a couple of steps, my total f net will be 6.8 times 10 to the minus 3 newtons. Okay? But please make sure, recheck if I've done this correctly. Is this it? This should tell us what the total force is? No, you're right. This only gives the magnitude of the force, but we need a force to be a vector. What else do we need to do in order for it to be a vector? Yes, we need direction. So how do I find the direction? Aha! Now, in order to calculate the direction, what do I have to do? So I have my F net equals to 6.8 times 10 to the minus 3 newtons, right? That is only the magnitude. But in order for this to be an actual vector, I need theta as well. Well, I'm going to call it phi because I already called it theta. So I'm going to call it phi. How do I find phi? Tangent inverse of Fy over Fx. Where am I going to get Fy and Fx? These values. So remember I told you to find these values? This is where that's going to come in handy. So I'm going to give you the values I get. I get minus 5.79 times 10 to the minus 3 newtons divided by minus 3.53 times 10 to the minus 3 newtons. Once I have that, I can calculate theta, and my theta comes out to be that.